Use the graph to answer the questions. For number 1 and 2, you're going to write the coordinates or the ordered pair for the points. And then in 3 and 4, you are going to write the letter that corresponds to those coordinates. Here we see a map. I want you to think about some of these questions. If Kelly walks from the bookstore to the cafe and then to the Chinese garden, what do you know about the distance that Kelly walks? So if she starts at the bookstore, goes to the cafe, and then to the Chinese garden, what might you know about the distance they walk? Well, it looks like she would have to walk 3 blocks this way and 2 blocks that way, which would give us 5. Then she's going to have to go back this direction. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 blocks. But we don't know how many miles or how many kilometers or how many feet or yards. We don't have any units for those distances. Coordinates could also be a helpful tool for identifying locations on the map. In order to create a coordinate system on a map, we might want to know the location of 0, 0, or what we would consider the origin. Where might you place the origin on this map? So perhaps you would place it here, because it goes straight out to the right from there, all the way across the river and up. These sections down here aren't quite like a grid or a graph we see in a traditional setting because they are slanted. Why do you think most modern towns and cities have streets that vaguely resemble a grid? It makes it a little simpler to navigate your way through a town if it's set up in a grid-like pattern. We're going to work with some grids and some map work today. Number 1 says draw a rectangle in the coordinate plane that satisfies each of the following criteria. Identify the ordered pair of each of the rectangle's vertices. Remember, those are the corners. First, each of the vertices lies in a different quadrant. The perimeter is 38 units. And either the x or y axis, not both, is a line of symmetry. So let's think of some different values we could get that would give us a rectangle with a perimeter of 38. Let's say we did 10 as one of our side lengths. Well, 10 plus 10 is 20. So that leaves us with 18. And then we would put 9 on each side because 9 plus 9 equals 18. So if we want our x-axis to be the line of symmetry, we would need the x-axis to cut it in half. So it would be 4.5 and 4.5. That might be a little more challenging than if we made the y-axis the line of symmetry, because then we would have 5 on each side of the y-axis, because 5 plus 5 is 10. So let's try that one. We're going to go up 3, or over 5 and up 3. And then we're going to go back 5 and up 3, because that will give us that distance of 10. Now we need to go 9 down so that we end up in all the different quadrants. 1, 2, 3, 4, 5, 6, 7, 8, 9. and 9 down from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if we connect these, that would give us 10 there. So our axis of symmetry is the y-axis, not the x-axis, because there's 3 above and 6 below. So it's not symmetric over the x-axis. The perimeter is 38 because 10 plus 9 plus 10 plus 9 equals 38. And I have a vertex in each of the 4 quadrants. We need to also identify the ordered pair. So this coordinate is 5 right and 3 up. This one is 5 left and 3 up. This is 5 left and 6 down. And this one here is 5 right and 6 down. Now keep in mind, this is not the only possible outcome. There are plenty of other values that we could use that add up to 38 and would still satisfy the other criteria. Number 2, draw a rectangle in the coordinate plane that satisfies each of the following criteria. Identify the ordered pair of the rectangle's vertices. The vertices lie in exactly 2 quadrants, so we can't put them in all 4. We only get 2. The figure has exactly 2 sides that are each 6 units in length. And the y-coordinates of the 4 vertices have the same absolute value. So if we made our rectangle go this direction, the y-coordinates of our vertices would not match because we would have one below and one above. And we can't put them in 4 quadrants, like say a +2 and a -2, because then we don't satisfy this criteria. So we actually are going to need the rectangle to be drawn vertically in 2 quadrants and cross over the x-axis. So let's see. If I made it have a segment that was 6 long, this has the coordinates 8, 2, and this one has the coordinates 2, 2. If I want the y-coordinate to have absolute values that are the same, I need to be at 2 or -2. So this is 8, -2, and this is 2, -2. I have exactly 2 sides that are 6 long, because these ones are 1, 2, 3, 4. And it's only in 2 quadrants. It's in quadrant 1 and quadrant 4. You are helping to create a map of a town. Use the coordinate plane to create a map of a town that meets the following requirements. Each location must be represented on the map. Do not extend the town boundaries. The point for each location must be plotted where 2 grid lines intersect. Each square on the grid represents 1 block. Each line on the grid represents a street. Plot a point to represent each location on the map. Label each point. The fire station is located at 50. The fire station is directly east of the town hall. It may be helpful to draw Oops, not an S, that's supposed to be a W. If it's directly The fire station is directly to the east of the town hall. That means that the thing is to the west of it. So we're going to place it to the left to be west of it. So the fire station is to the east. And that is the town hall. So I'm going to label it with TH for town hall. Then it says the police station is 6 blocks above the fire station. So 6 north is going to go 6 above. 1, 2, 3, 4, 5, 6. And that is the police station. The school is northwest of the town hall. So the school is north and west of the town hall. It doesn't give us specific units or blocks for the school. So we're just going to go north, so up and west, left. And that is the school. The distance from the school to the police station is equal to -3's absolute value plus 5 blocks. That is 8 blocks from the police station. So we do have to readjust to make sure it is 8 from the police station. 1, 2, 3, 4, 5, 6, 7, 8. So the school is going to need to move to this location here. Then we also need to check and make sure, is it still northwest of the town hall? Yes. It is up and to the left just slightly. The ice cream shop is 5 blocks west and 2 blocks south of the town hall. So 5 west and 2 south for the ice cream shop. So 1, 2, 3, 4, 5. 1, 2. That is the ice cream shop. The museum is within 5 blocks of the town hall. Does it say anything else about the museum? It says something about the library. Okay, so the museum is within 5 blocks, so that means 5 or less from the town hall. And it doesn't give us a specific direction, but I'm going to make it south. I'm going to say it's 4 blocks. 1, 2, 3, 4. That would be within 5. The library is no more than 3 blocks from the museum and no more than 5 blocks from the school. Okay, we're going to have to readjust here. Because even if we put the library 3 blocks from the museum, getting it closer, that's still 1, 2, 3, 4, 5, 6, 7, 8 from the school. So let's go back and reevaluate the things we know for sure. We know the fire station is in the correct location. So that one's going to stay. We know the police station is 6 north, so that one's in the correct spot. We know the distance from the school to the police station has to be 8 blocks. We counted 8 that direction, so that one's in the correct spot. I believe we can move the museum the other direction to make it closer to the school. That way the library is also closer to the school. So we're going to move the museum. It says the museum is within 5 blocks of the town hall. So it doesn't have to be to the south. It could also go to the north. So we're going to go within 5 blocks, but we're changing its location. So, oops. Instead of south, we can make it go north. 1, 2, 3, 4. It's within 5, so that works. And then it says that the library is no more than 3 blocks from the museum and 5 blocks from the school. So we can put the library in here. If it's 3 blocks or so from the museum, it can go here. And then that's 1, 2, 3, 4 to get to the school from the library. So that satisfies those requirements. Now there's several other positions you can place these to still make sure they're satisfying all of those requirements. B. Adesh needs directions from the school to the fire station. Describe a route using streets on the map for him to follow. What is the total number of blocks he walks if he follows that route? So we're trying to get from the school to the fire station. He can walk 1, 2, 3, 4, 5, 6, 7, 8 blocks east. And then 1, 2, 3, 4, 5, 6 south to get to the school to get to the fire station from the school. Eight plus 6 is 14. You could also phrase it as he can walk from the school to the police station, and then from the police station to the fire station, which would get him in the same route, still 14 blocks. Here are some real world maps. We can zoom in a little bit. This particular map shows a part of the historical map of San Francisco in California. The letters of the horizontal axis and the numbers on the vertical axis indicate a type of grid on this map. So you can see it's pretty teeny tiny. There's some aspects of a grid here. How is the grid on this map similar to the coordinate plane, and how is it different? So you can see again, it's similar because it divides it into horizontal and vertical sections, but it's different because the origin would actually be in this upper left-hand corner. You can see that the numbers along the side start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it has letters instead of numbers as A, B, C, D, E, and so on. So it's not quite like the grid for the streets, but there's a grid system that would be sketched in here going based on the letters and the numbers more so than the streets. But they don't draw those lines out on the map. So instead of having an ordered pair like 0, 0, you might have an ordered pair that has letters and a number. So for example, if we looked at a specific location here on the map, like this Fort Mason, that would be at the coordinates B2. We also have some kind of coordinate system for our globe. we have this diagram of the Earth, and we have lines of latitude, which run east and west. And lines of longitude, which would go north and south. This map shows the longitude and latitude for this city, Buenos Aires. And then we also have the equator, which represents a latitude of 0. The prime meridian represents a longitude of 0. If you look at the North Pole, up here at the top, what do you notice about the degrees of latitude of the North Pole and of South Pole? Those are opposites. You have one with 90 degrees and one with negative 90. Where else might you see opposites here? You can see the Arctic Circle and the Antarctic Circle as 66 and 66, but this one has the N for north and the S for south. And here we have the map of the United States. Why might these lines not be vertical or horizontal? Why do you think they're curved? Well, if we look back at the last picture, our globe isn't flat. It's three-dimensional, so there's curves that go around the outside of the globe. Since the Earth is curved, the lines have to be curved also. The northern part of the US is closer to the North Pole, so the lines of latitude are closer together. And then farther south, the latitude gets wider at places that are closer to the equator, that line that represents 0. This map shows the lines of latitude and longitude on the United States map. In what state is the ordered pair 110 west and 40 north? So here's 110 west and here's 40 north. That falls in the state of Utah. You can also use this to represent where your school is. Or you can think about San Francisco being in California. You could say California would be approximately 120 west, and San Francisco is closer to 40 north than 30 north. Make sure that you have your workbook filled in for lesson 17 and your warm-up completed.